In a carnival ride, passengers travel in a horizontal circle of radius of 5.3 meters. The maximum safe sustained acceleration that riders may experience is 20 meters per second square. Letter A. Find the period of the ride when it is being operated at the maximum acceleration. Letter B. How fast are the riders moving when the ride is operated at this period? A body that moves in a circular path at a velocity whose magnitude is constant is said to undergo a uniform circular motion. From one of our previous lecture videos, according to Newton's second law of motion, kung walang force na nag-aakt sa isang object, it will move with constant speed in a constant direction. So force is required to change the speed, direction, or both. For example, a vehicle is moving with constant speed on a circular motion. The direction of the motion of the car ay nagbabago continuously. So a force must act on the car to cause this change in direction. So in that example, usually we calculate two things under the force na nagkukos ng circular motion. Una, yung kanyang magnitude, and pangalawa, yung direction. If we consider the direction of the force, for example, we have a man here na nagsiswing ng ball na nakatali sa isang string, horizontal circular motion above his head. Habang siniswing nung man yung ball, mafe-feel niya yung tension in the string pulling outward. And of course, on the other end of the string naman na kung saan naka-attach yung ball, the tension pulls inward, papunta dun sa circle. Yung force na nararamdaman ng ball is a force that is always directed toward the center of the circle. In summary, to make an object move in a circle with constant speed, a force must act on it that is directed toward the center of the circle. And because the ball is acted on by a force toward the center of the circle, it follows that it must be accelerating toward the center of the circle. The acceleration is produced whenever the speed or direction of the velocity changes. And sa circular motion in this topic, yung direction ay nagbabago continuously. And yung nararamdaman na center-directed acceleration ay tinatawag natin as the centripetal acceleration. This acceleration is also known as the center-pointing acceleration or the radial acceleration since it is directed along the radius toward the center of the circle. In this figure, yung nakikita natin na yellow, these are the centripetal accelerations. And itong green, ito naman yung mga velocity. Take note, itong mga black dots na ito yung kanilang, ito yung position ng object na kinoconsider natin. Like for example, itong ball na naka-attach sa string, ito yan. Take note that the speed is the same at this point and at this point, pareho lang sila ng speed but the direction of motion is different. Pare-pareho sila ng speed pero yung kanilang direction ay magkakaiba. And a changing direction of motion means a changing velocity and hence an acceleration. The magnitude ng centripetal acceleration na to na kung saan yung kanyang direction again is toward the center of the circle is calculated with this formula. So A sub C or centripetal acceleration is equal to velocity square over r, where yung A is the centripetal acceleration, V is the velocity of the object, and yung r naman is the radius of the circular path. And again, dahil yung acceleration ay perpendicular to the path followed by the body, yung velocity ay nagbabago lamang in direction, not in magnitude. To provide an object a circular motion, a centripetal force must be applied. Centripetal force is the inward force that must be applied to keep the body moving in a circular motion. Kapag walang centripetal force, circular motion cannot occur, and since yung force natin is equal to mass times acceleration from the dynamics na chapter natin, the magnitude of the centripetal force on a body in circular motion is calculated by this formula. Centripetal force is equal to mass times velocity square over r. So this velocity square over r na yan is simply the centripetal acceleration. Kaya nga, from this equation siya na-derive. Force is equal to mass times acceleration centripetal. So kaya, itong force na to is the centripetal force. pwedeng makapag-produce ng centripetal force in different ways. For example, pwedeng yung tension sa spring, like yung figure natin kanina, or pwede rin naman due to friction between tires and the road. Madidiscuss natin yung mga ganong example sa next lecture video. Thus, yung centripetal force na yan is a force that must be present to cause a circular motion, as we have said earlier. But the specific cause of the centripetal force varies from system to system. Circular motion is often described in terms of frequency. So what is frequency? Frequency is the number of revolutions per second. Another, tinatawag natin as the period, or denoted as T. The period or T of an object is the time required for one complete revolution of an object revolving in a circle. And in circular motion, meron tayong relationship for frequency and period using this formula. Period T is equal to 1 over the frequency. And for example, in this figure, isa-solve natin yung velocity using the main formula natin as the distance over time. In circular motion, yung distance na i-consider natin is yung distance nung circle or yung circumference. Itong broken line na yan. So, ang ilalagay natin sa D is, for example, 1 revolution na gagawin natin, i-consider natin yung buong circumference ng circle. Ang formula natin for that is the 2 pi r over time. So, this is how circular motion works. A ball is whirled at the end of a string in a horizontal circle 50 cm in radius at the rate of 1 revolution every 2 seconds. What is the ball's centripetal acceleration? In this problem, ganun sa figure natin kanina, horizontal circular motion, say this is the string, and ito yung ball, meron siyang horizontal circular motion. And tinatanong sa atin is the ball's centripetal acceleration. Formula for centripetal acceleration is A sub c equals v square over r. Alam na natin yung radius nung circular motion, we have 50 centimeters. Kaya lang hindi natin alam is yung velocity. Eto, to solve for the velocity, we just have to use the main formula. Velocity is equal to distance over time. And again, take note na nabanggit natin kanina, yung distance ay hindi yung straight line distance, kundi yung distance na natatravel nung ball. Ito siya, papaganyan, papacircle in a circular motion. To solve for that, yung distance is equal to 2 pi r, 2 times pi. Ang value ng pi natin is 3.14 something. And yung r natin is given again, we have 50 centimeters. So, yun yung distance. To solve for the distance, we have 2 times pi. Ang radius natin, we have 50 centimeters or 0.5 meters. Distance is equal to 3.1416 meters. Ito yung distance na ilalagay natin to solve for the velocity. Solving for the velocity, we have 3.1416 meters divided by the time, we have 2 seconds. Velocity is equal to 1.5708 meters per second. Ito yung velocity na ilalagay natin dito to calculate the centripetal acceleration of the ball. Centripetal acceleration is equal to velocity, we have 1.5708 meters per second quantity square divided by the radius 0.5 meters. Centripetal acceleration by calculating is equal to 4.935 meters per second square. So this is the ball centripetal acceleration in this given circular motion, and this is example number 1. Example number 2, a vehicle with a mass of 980 kilograms rounds a turn of 32 meters radius at a velocity of 9 meters per second. Find the required centripetal force. For the centripetal force in this problem, we have the equation F sub c, or the centripetal force itself, equals mass times velocity square over r. Given na sa atin yung radius, we have 32 meters. We also have given the mass yung 980 kilograms and given din sa atin yung velocity. So therefore, direct substitution na lang kailangan natin gawin to calculate the centripetal force. Centripetal force is equal to mass is 980 kilograms times the velocity. We have 9 meters per second quantity squared divided by the radius na 32 meters. By calculating, centripetal force is equal to 2,480.63 Newton. This is the centripetal force in this horizontal circular motion problem, and this is example number 2. Example number 3. In a carnival ride, passengers travel in a horizontal circle of radius 5.3 meters. The maximum safe sustained acceleration that riders may experience is 20 meters per second square. Letter A. Find the period of the ride when it is being operated at the maximum acceleration. Letter B. How fast are the riders moving when the ride is operated at this period? In this problem, we will assume that yung ride are in uniform circular motion. Say for example, top view, ito yung ating circular motion. This is the ride, pinagsasakyan ng passengers, and ito yung kanilang centripetal acceleration. This is the velocity, and ito yung radius ng circular motion. Ang unang hinahanap sa atin is yung period or yung t. We are asked to find the period or the t of the ride when it is being operated at the maximum acceleration. And again, we can use the main formula for the velocity, the distance over time. And nabanggit natin kanina, in circular motion, yung distance is ang gagamitin natin yung circumference. We have 2 pi r over the time, or simply 2 pi r over the period t. So we have velocity is equal to 2 pi r over t. Kaya lang, hindi natin alam yung velocity. Ang given sa atin is yung centripetal acceleration. So we cross multiply first. T is equal to 2 pi r over the velocity. For the velocity, pwede natin gamitin yung centripetal acceleration na formula, v square over r. So we cross multiply this one. V square is equal to r times the centripetal acceleration, and we take the square root of both sides. So we have v is equal to the square root of r times the acceleration centripetal. Pwede na ito ang ilagay natin dito. T or the period is equal to 2 pi. Ang r natin is 5.3 meters divided by the square root of r, we have 5.3 again, meters times the centripetal acceleration na 20 meters per second square. And by calculating, ang period natin or the t is equal to 3.23 seconds. Ito yung period. For letter B naman, how fast are the riders moving when the ride is operated at this period? Simply, solve na lang natin using this derived equation. Velocity is equal to square root of 5.3 meters times the centripetal acceleration at 20 meters per second square. And by calculating, ang velocity is equal to 10.30 meters per second. One rotation in just over 3 seconds seems reasonable for a carnival ride. Ang period na ginagamit, particularly for this kind of ride, ay 3.7 seconds. So it runs a bit slower than the maximum safe speed, and this is example number 3.